Awesome. Welcome everyone to the session. Today we are actually going to be covering the HoloLens. So I'm just going to briefly talk about my experience with the HoloLens. I think it's amazing to go and explore. I just had like a week experience with the HoloLens and I did this project. You can check out on my YouTube, I guess. But it's very fun. You have people here who are very experienced with the HoloLens in general, so they'll be able to go into more detail today in the session. You've got a lot of amazing things which you'll be exposed to today. So I'm here with Cinder and everyone else here, and I will go ahead and let Faizan introduce.
Yeah, hello everyone, and welcome back to another amazing Immersive episode, this time in mixed reality domain. As you might have seen the poster, the session is titled HoloLens with Mixed Reality. And guess what? We have Julia Schwarz here with us, who is a super personality. Just to mention, she loves outreaching. So she loves to join as a speaker to various events. Her last online webinar on extinction interaction got more than, I would not share the exact number, but just say more than 1K registrations. So just she's a super great personality. And here we are joined by Aparna Mittal ma'am, India region country program manager. So yeah, we are really excited for the session today. And so let's just start with a quick intro. So hi Julia, thank you for joining us.
Oh yeah, thank you for having me.
Yeah, can you briefly introduce yourself?
Julia, you are on mute.
Yep, sure, yeah, happy to introduce myself. Yeah, I'm an engineer on the HoloLens team, and I work on the input and interactions. So the fact that you can, reach out and touch holograms, I did a lot of that work to make that happen and make it sort of usable by people via the mixed reality toolkit as well. Worked on that as well.
Yeah. All right, that's great. That was a great session, and we are really excited to see what Julia is going to share with us today. So, all right, our next speaker is Keng Chi. So, can you please introduce yourself, Keng Chi?
Hi everybody, I'm Cheng Hing here from the Singapore team. I was a Microsoft student partner and still am currently in Singapore Management University. I actually run a startup over here in Singapore called Hello Holo that we actually work on the mixed reality devices since 2016. Very happy to actually have the HoloLens 2 with us as well, and we'll be excited to actually share what we have done as well as enable everybody to use the device as well as being able to develop for it. Thank you very much, Faisal.
Yeah, all right, thanks. And next is me. So, hi, I'm Faizan, a Microsoft student partner from India, currently pursuing bachelor's in computer engineering. I have a keen interest in mixed reality domain and have been playing with this for a year now. And I was privileged to get HoloLens from my college. So I also decided to do my final year project in the same mixed reality domain with my great teammates, and it's titled Mixed Reality in Organic Chemistry. So so just to know more about me and my socials, you can visit my portfolio faizanakhtar.com, where you can find other stuff about me. All right, so that was a great intro, everything. So all right, so without any further delay, I'd say let's get started. Can you share your screen, please?
All right, the screen should be up.
Yeah. Okay. So this is our poster branding poster where our guest speaker is Julia Schwarz, and we are pretty excited. So the session has two main points. So I'll tell you later what are those 2 points. So let's just go a quick read through the agenda. So next slide, please. Alright, so this is today's agenda. So we are going to first start with some basic terminalities, VR, AR, MR, and what exactly is the difference between these 3 domains, and which is pretty much required to every newbie. And I hope many newbies are joining here today. So that we'll do here. Then next we'll go and know what exactly a HoloLens is and what it can do. Then as HoloLens was released in 2016, and since then many improvements have been done, and HoloLens 2 was released in 2019. And guess what? Julia Schwarz was the one who launched HoloLens 2, and it was a great demo. And then we are going to proceed with some of the use cases in industry, where how HoloLens has been useful to various domains in the industry. And then here comes the next two main parts of the session. First is you are going to see live demonstration from HoloLens 2. We have some cool apps, so you will see those 3 apps demonstrations here. And the next, we have just renamed the whole section to Julia Schwarz. We are really excited to see what she shares there. And at the end, we are going to have a Q&A section. So just stay with us up till end, and I would really give a shout out to all the audience in the chat. So if you have any question, just keep it up till the Q&A section, or just type in the chat. Someone from the team will just save it and will try to answer it in the Q&A section. All right, I will now pass on to Ki Cheng Heng, and he will carry you forward from here.
All right, thank you very much, Faizan.
Yeah.
Yes, so I'll be sharing a bit more on this section itself, as well as today's keynote. Our key objective over here is really to enrich the community with these mixed reality technologies and really help developers and companies build the next generation of applications and experiences over here. All right, so I want to start off by helping everybody understand what exactly is extended reality and why are there so many different types of realities itself. So within the extended reality, it actually encompasses 3 key areas, starting from virtual reality, augmented reality, as well as mixed reality. And effectively, in virtual reality is where we are occluded from our surroundings. We can't see our surroundings at all, and all we see are just virtual elements. And in augmented reality, we are talking about 2D overlays within our real world. And most importantly, it doesn't really have much context of our surroundings. Whereas mixed reality, that's where it actually has 3D overlays within our scene and effectively is able to understand our environment actively. And what I mean by that, imagine now I pick up a virtual ball, I'm able to drop it onto a physical table, it's able to roll across the table, drop off the table, fall onto a floor, and bounce off the floor. And that itself is mixed reality. And effectively, within the entire extended reality structure, it's under the immersive media umbrella. And within the immersive media umbrella itself, we do see other elements such as projection mapping, cognitive services, and even more. So what exactly is mixed reality and how do we actually make use of it? So number one, within mixed reality itself, we are finally able to interact with 3D in real time. And what does that mean? Gone are the days that we actually have to present 3D models on a 2D screen. Effectively now, we are able to present these items within your real world space itself. We also have what we call room scale experiences in any rooms. So what does that mean? Nowadays, game developers no longer have to focus on creating game stages within their own game itself. And what you're able to do is make use of the player's environment and being able to create game dynamic codes that can effectively roll out these room scale experiences. You can write codes like, for example, spawning three monsters on a small floor, 6 monsters on a large wall, and effectively you can clone this across all dimensions, and pretty much you actually have a new gaming experience in every single room you go into. Next, we also have what we call a new frontier of applications for mixed reality. Effectively, I'm sure all of you have tried Skype for Business back then. Now we are on Microsoft Teams. And effectively with Teams itself, we are actually activated with Dynamics 365 Remote Assist. And what that happens is you're now able to dial from one location to another location with a HoloLens device together with a Windows computer. And most importantly over here, you can ink, draw, and annotate within your space. And pretty much nowadays, what that activates for clients as well as enterprises, you no longer have to send 6 to 7 technical team members across long flight journeys just to assist a client with some sort of maintenance. All you have to do is send one on-site engineer, enable them with a HoloLens device, and effectively, you can just do that and use that to actually call your premium as well as expertise within your headquarters itself. And yeah, pretty much that is the new frontier of applications for mixed reality. Next, we also have the various pros and cons. Of course, in mixed reality now, we are able to interact with 3D digital content with spatial context. And most importantly, you're hands-free as well. You also have face-to-face human connection. And throughout all experiences, I can't stress how important it is to really maintain that face-to-face connection with whoever that you're actually interacting with. And with that, we actually activate collaboration with others, having multi-users in the exact same scene at the exact same time, effectively being able to play with the exact same 3D model. We also have active scanning of your environment without the need of purposeful scanning. All we have to do is just put on the headset and we can actually see the entire environment mapped out in a 3D mesh. We also have gestures and interactions. Now with HoloLens 2, we have the ability to actually use all 10 fingers to actually create such interactions. Of course, everything is still a developing technology. We definitely see HoloLens improve leaps and bounds with HoloLens 2, and we are sure there's going to be more to come. Within the immersion itself, it's actually a bit limited, but definitely it has its own use cases as well. All right, and within here, this is Microsoft HoloLens, the world's first fully untethered holographic computer. This is version 1. It has a see-through lens, it has 4 advanced sensors, and as well as a holographic processing unit. And this, effectively, is the HoloLens 2. Now I'll be sharing a bit more with a video. All right, and within this mixed reality toolkit video that I'll be sharing, effectively, it shows what you can actually do with the HoloLens 2 device. You're able to click on buttons, even play the piano as well. And you can see how these all interactions of virtual elements are extremely interactive. You actually have slider use cases as well. It's able to detect all 10 fingers, having a hand mesh and hand join. And most importantly, you observe over here, you're not even wearing a glove at all. And you are able to pick up a virtual object, scale, rotate, resize them, bring virtual objects and collide with each other. And most importantly, you can see how each of these objects have a real-world understanding of you in your environment. You no longer need a VR-ready computer. Yes, you can touch on the server use cases, but definitely everything is self-contained within the headset. Of course, you have near gestures, far gestures. All these are all possible use cases. Interactions can be done by a keyboard, and pretty much you also have a hand menu that you can actually explore with as well. And of course, within all of this, there's definitely one more most interesting thing, which is iris identification. Pretty much you're able to use your iris to actually log you in within the entire device. It's able to detect who you are as a user. And as well as when you're reading a text, you're actually able to automatically scroll down once you actually finish reading. It's also able to understand what exactly you're looking at and pretty much activating analytics use cases as well. And that itself is an introduction to what HoloLens 2 can actually enable you to do. All right, after this, I'll actually hand over my time to Faizan, who will actually continue with the next part. Faizan, please.
Yeah, all right, that was a great intro part, and the first part went great. So I'm hoping that my part also goes that great too. So continuing with so evolution at its finest, so how we have moved from Microsoft HoloLens to Microsoft HoloLens 2. There have been certain improvements. We will be talking about them in the upcoming slides. So can you go on to the next slide, please? All right, so this is some of the technical specifications of HoloLens. That what are some technical specifications of that particular device. So this might be seeming a lot for an intro or for a newbie. So just if you are interested, you can check some of these. You can check these again, and you can check these specifications on the HoloLens website too. So I'll just move on to the next slide. Yeah, so now we will talk about some of the improvements that were done in HoloLens 2 and how HoloLens 2 became so great. So the first improvement that was made was the viewport through which you view. It was increased almost up to double from 30 degrees to 52 degrees, and also maintaining the 47 pixels FOV. So this is how the improvement was great. So it was done from such a small viewing screen to such a big screen, so that you can experience your virtual objects more with more reality and more experience. So next slide, please. All right, so the newest feature, which is exclusively for HoloLens 2, is eye tracking. So you can, as you might have seen in the MRTK mixed reality toolkit video, so just with the motion of your eyes, yeah, the virtual objects can respond to your eye movements. So like if you want to scroll a screen, you can just scroll your eyes, the screen will keep on scrolling. So that's how real time it will, and obviously security is there. Next slide, please. Yeah, so this is the continuation of previous slide, so showing how eye tracking is being great. So from eye gaze based auto scroll, then attention tracking, and then combining all of these eye gaze with other inputs. So if you want to combine two with a hand gesture and eye input, so you can do that. So this is how the improvement was done from HoloLens 1. So reducing making the user to make minimal efforts to just perform an action if you are too lazy. All right, so let's move on to the next slide. And this is also for HoloLens 2 exclusively. So the HoloLens 1 was, I guess, it tracked around 5 fingers, but now it tracks all of your 10 fingers. So if you just scan all of your, bring your hands in front of HoloLens 2, all of your fingers, and locate each of, not only just scan your fingers, it will locate each of your joints, each of your hand joints, and every palm, so that as you can see in the slide, so 26 points of articulation per hand, that not combined of both hands, per hand it will recognize up to. That's how precise it will be. And there's a new experience like interactual, it more interactive. So let's move on to the next slide. Alright, so these are some of the other improvements here. So like the weight was reduced, weight was almost reduced by 10 grams, but usage is 10 grams. So, but it's not just for saying, but if when you wear a headset on your head, and if you each gram of weight really matters. So it was reduced from I guess 580 grams to 566 grams, and ergonomically. So if you want to say, so it has a carbon fiber material, then it actually has a flip up ahead of it. So like if you want to just turn off from your world.
I think we're losing Faizan. Is it just me?
And in terms of hygiene, sorry.
I think we're losing
You are kind of
connection with you.
breaking up.
All right, is it okay now?
It is fine right now, so you can
Like
continue.
coming and going. Sorry about the technical difficulties, everyone. If you have any questions, do put them in the chat and we'll try to cover that for you.
Alright, so can you hear me now?
Yeah.
Okay, sorry for the interruption. Okay, so as I was talking, can you tell me up till which part I was audible?
Just like
So I
one or
can
two
continue from there.
sentences.
All right, so I would just repeat this slide again. So just the weight has reduced by almost 10 grams, 10 to 20 grams. So it really matters when you wear a headset on your head. So really each gram of weight matters there. Then if you want the carbon fiber material, which makes it more ergonomic. So, and it really has now a flip up for changing from one reality to other. So if you want to turn off your virtual reality and from your mixed reality to your actual reality, so you just have to flip off your the flip, and you'll just be in the new reality. And in hygiene, it's wear and tear resistant, and it has a detachable forehead cushion, so it gives a relief to your head. So when you wear your HoloLens 2. Next slide, please. All right, so now like HoloLens was introduced from 2016, and since then it has been making a really impact in the real world. And now let's see how companies and organizations are using mixed reality with HoloLens. All right, so the first domain in which the mixed reality was used is obviously architecture, design, and construction. So just you can see how an architectural design can be just seen easily in a 3D way. So you can now not gone those days where you have to just see 3D model on a 2D screen. You can just experience the 3D model on using a HoloLens. Sorry for that. And now Trimble SketchUp is also available for HoloLens. So it's one of the first publicly available commercial solution for this domain. All right, next slide. All right, the next slide is engineering. So like engineers are always as creative, but still engineers are using many new things to improve their daily things. So first is like physical limitations of training simulations. Like if you want to just repeat the same training for the same person, so instead of just repeating it again physically, you can just record it once. So as you can see in the picture, so the same 3D content which you are viewing there, it can be shown to as if you want to show it to a new worker or you want to show it to a new student and many much more. And PTC before a studio is is the first is one of the first that has got into it, and it's also combining this domain with IoT by getting many more features with it, so that it actually it can give you a model to from 2D to 3. It can give you a conversion from 2D to 3D and interact with it. All right, next slide. Next domain is medical, which has been really using mixed reality. It can be so for like if you want to do some virtual surgeries, and as we can see that in the picture, the surgeon is wearing a HoloLens, and he or she, the person, is receiving the training from someone else from a remote place. So it's like if you are in operation theater, you can just bring in someone in there and ask him or her to how to do this. Instead, you can just virtually contact the person, and just if you want to know something. So it's like basically many hand-free interactions are allowed in this, and real-life volumetric display of autonomic models are displayed here. And Philips Azurion is one of the product which is integrating live X-ray and ultrasound and other surgical data into mixed reality. All right, next slide. The consumer and retail product demo has been also a domain which has been really using this technology. So in this, if you go to buy a furniture in a but if you want to just check out the furniture, how will it look at your place? So if you want to buy it for your place, or if you want to just look how that particular furniture will look there, so it's really hard taking that furniture physically and placing it in your room. So if it look good, then you're lucky. But if it doesn't, so what would you do in that case? So it will be really tedious. So you can just actually wear HoloLens, and you can view that demo, and you can just place the objects in your real world and see that how will it look after many real things are placed there. So many stakeholders are behind this domain. So yeah, so it's pretty cool domain type. All right, next slide. Next slide is consumer and retail product shelving. So if you want to so you can just visit a showroom without going actually with the showroom. So this is kind of can be useful in this current COVID-19 time. So if you want to just view something and physically how would it look. So like if I will give you an example of, suppose if you want where to buy a watch, so if you want to just try it, so instead of going there and physically trying it, you can just virtually try and look at your wrist, how will it look. All right, next slide. Next slide is actually one of the greatest domain where mixed reality has been used. So using HoloLens. So first thing is like daily, every day, new workers are being joined in manufacturing. So and they all they will obviously require a training, like they are newbie, so they will require training. So instead of just going there, as I mentioned in the previous slides also, so instead of going there and training them physically, you can just record a session with mixture or wearing a HoloLens, and just let them view that, so that if they want to do they want to perform some operation, they can also perform in real time. And suppose if some things like some issues happen, and if you want to seek for advice from a remote person, so you can just you can using a working space, so you can just contact the person, and the person from there can actually draw virtually in your real-time environment and show, like, yeah, this is the part where you should open this screw, and this is the part where you should fix it, this is the part where there is a. So I guess you're getting me. So that's how manufacturing is being using this mixed reality domain with HoloLens. All right, next slide, please. Financial services. All right. So this is kind of a new domain which has been using mixed reality now. So as you can see in the picture, so just imagine all of your stock sheets and spreadsheets just viewing instead of just viewing them in Excel. Excel is great, but viewing just them in a 2D, just imagine viewing all of them in three-dimensional space and in an interactive way. So like, which actually you can walk around and see data patterns and trends which are just going on. So just imagine these things. So this is kind of new and new domain using this mixed reality. So yeah, pretty much it's still interactive. It will still look good. All right, next slide, please. All right, so this is a part from where about mixed reality developers toolkit, and I will invite Kengichi again to take on from here and tell it more about it.
All right, thank you very much, Faizan. Hope everybody has been tagging along in regards to the use cases. Very descriptive. So now that we move into more of the developer toolkit, we get to understand what exactly is the development process. So just to briefly run you all through, definitely we start off with analysis and wireframing. From Photoshop to Illustrator, we move into design, where we actually introduce Maya as well as Substance Painter, or even any other 3D tools and software out there in the market. After that, we actually move into more of development. That's where we're actually bringing Unity, Visual Studio, and of course, we also have Pixies as well. And what exactly Pixies do is more of optimizing models that are way too large for the device itself. And pretty much with the HoloLens 2 units, usually you actually deal with, within one scene, you're dealing with about 200,000 polygon count to keep at 60 frames per second. Of course, you can try and squeeze in about 1 to 2 million, but your frames per second will drop to about 20 or even 15 frames per second. You always want to keep that user experience as good as possible. Within the deployment and maintenance space, you definitely use on Unity and Visual Studio. All right, there's definitely other improvements within the entire scene. We do see the Trimble XR10 with the HoloLens 2 appearing. That has a hard hat attachment, and that also features a Bluetooth bone conductor sound system. And effectively, what that does is it helps whoever that's on-site engineers to make it as safe for them as possible, keeping their ears free, where they can actually wear earplugs, and pretty much the sound is being conducted through the bone conduction device. We also have a new IDE that actually joins the mix. We also have Unreal being supported. Now we'll actually jump into the live demo. I'll be showing 3 applications today, and let's see whether there's any issues with the live streaming. I'll be live streaming through the HoloLens 2 device portal. There's going to be about 1 to 2 second delay between the live streaming. I'll be showing you 3 applications: entertainment, engineering, as well as holographic guides. Let's begin. All right, I'll be placing down this headset, logging into the device portal, as well as launching the mixed reality capture elements. You'll be able to see my environment that I'm actually streaming in right here in Singapore. All right, I'll be starting the entire application. The first application I'll be showing you is entertainment, 3D tic-tac-toe. I believe all of you have actually played tic-tac-toe at first, right? So tic-tac-toe is the one that actually forms the first line within the game itself. But over here with 3D tic-tac-toe, we actually let you form the maximum number of lines by the end of the entire game. So what I have over here is a 3D playing field. I'm able to drag this 3D playing field all around. I can bring in 2 fingers, rotate and scale them accordingly. I can bring them closer towards me, grab it, move it up and down. I can use it 2 hands as well, and pretty much that's. I can also bring up different tokens. Lift up 1 hand, drop a ball, And effectively what I have over here is an AI that's playing with me. You can essentially pretty much bring in a multiplayer collaborative experience where you can actually introduce two players on two different separate devices and join the experience as well. All right. Effectively, I can just keep spawning the balls with my hand, and that's an interesting example of hand gestures. All right, let me go into the next experience. All right, the next experience I'll be showcasing is an engineering use case. And within this engineering use case, I'll be able to see a 3D model within my real-world context. All right, you can see how I have this 3D model in my real world. I'm able to stand all the way to the sides, take a look at it from different angles. All right, I can even look underneath the model and really try and understand it. I can click on adjust, pick up the model, rotate it. I can use two hands, resize it, and you can see how I can let go and it can actually snap back to its location. I can explode the entire model and split it up into its different parts. I can pick up certain elements and really just go in and see the entire scene itself and really understand how does these parts actually come together. All right, and this is really an example of assembly as well as disassembly. All right, so that's another interesting use case. All right, the last one. Let's show you what exactly is guides and how can a senior engineer and junior engineer learn together. Effectively, what we have over here is mixed reality training and what we call self-directed learning. No longer you need a senior engineer on site with you. You can actually be a junior engineer putting on a device and effectively being able to present from there.
Welcome to HoloGuide's engine oil experience.
What I have here over is observing the various tools. I'm able to see that I have an engine, car engine over here. I can see the explanation on top of it. I can bring it a bit closer to me and really rotate it to its different areas to really understand what are parts and components of a car engine. I can get introduced to various tools, oil filter wrench. Let's see what I have over here. This is a ratchet with socket. I do have other things like, for example, a funnel as well. Let's jump into the experience.
We will cover a safety checklist.
All right, we have voiceovers. We have a car list. We do have a car model as well as this safety checklist.
Consists of long fabric to help protect your arms and legs from cuts, scrapes, and burns.
All right, so once you're done with the safety checklist, you'll see how there's animations included within the entire scene.
Have you ensured that all these safety
and this really helps the engineer on site to go through the entire flow and effectively come up with what we call kinesthetic learning. I can also have muscle memory, really being able to lift up the car and really pressing the buttons accordingly. All right, let's lift it up to the highest edge. And from there, you actually ask me about this draining of oil. You can see very briefly the entire car model on top, as well as, most importantly, this car engine. First step is really to drain the oil. So let's see how we can actually do that. We see a tool over here. We have to drag it over. And this really helps the engineer go through the flow and process.
The oil will flow back. Using the breaker bar, bring it to this position. Turn anti-clockwise to loosen the oil drain plug. Using the ratchet with a socket, bring it to this position. Loosen the oil drain plug anti-clockwise until unscrew the oil drain plug slowly in an anti-clockwise motion. Let the oil.
All right, you can always bring the different screens around as well, and effectively that will help us in the entire training process.
Screw the oil drain plug back.
All
in
right,
clockwise
and that
motion
is
by
the
hand.
demos. All right, thank you very much. Do let me know if you have any questions within the chat. Back to you, Faizan.
All right. All right. So that was a great demo. So I hope that all of the audience loved those three apps. It was really interactive and showed real life interaction. So and showed these that mixed reality can have various applications in real life. All right. So now we are done for the demo. And before we proceed, I would just like to give a shout out again to all the audience in the chats for showing up the excitement. So, and I would repeat it again, if you have any questions, just feel free to type in the chat or just save it up to the Q&A section. And let's now move on to the most exciting part of the session. And I would invite Julia Schwarz to take on from here. And I hope you enjoy here. All right, Julia, all yours now.
Okay, yeah, thank you very much, Faizan and Chenghe. Great presentations. Really good introduction to the HoloLens, which is great because that means I basically don't need to introduce it. And so what I was actually asked to do was kind of give a preview of what sort of the behind the scenes of building HoloLens 2 actually was, because as you see the HoloLens 2 and all the things it can do, I was sort of spending the last 5 years actually building the product on the team that built the software that made the UI for it. So I was going to give you a little bit of a just peek into what that was like and the prototypes we built in order to enable hand tracking on HoloLens 2 and build that UI for the first time on these AR devices at sort of the level of fidelity that we have. And also wanted to, since this is mainly an audience of students, I remember being a student myself, it was not that long ago. So I wanted to give you a view of how you can go from being an undergraduate student to getting to ship incredible products and make your dreams come true. So I'll give a little bit of advice there. So just a quick agenda, as I mentioned, I'll start by talking about my journey getting to Microsoft, actually. And we'll talk a little bit about the prototyping and work that went behind shipping HoloLens 2 and the instinctual interactions, the touching holograms. And then I'm going to close off with some suggestions and advice and tools that you can use to get started with HoloLens, even if you don't have a HoloLens headset. So starting off, I wanted to start actually at the end, or not the end of my journey, but closer to, I guess, what I guess I'm known for, a little bit of an introduction. So I think my biggest claim to fame is getting to do this demo. And I guess you might wonder, how on earth did an engineer, so I'm an engineer, I'm not a business executive. I've been at Microsoft for 4 years now. And how on earth did some young woman like this get to do such a high profile presentation? And the really amazing thing, and I have to thank my colleagues at Microsoft for believing in me, especially Alex Kipman, is that I really am an engineer. I'm not sort of a presenter. And I actually was able to communicate the enthusiasm for HoloLens and this basically getting to touch holograms, because that is what I'd spent the last 5 years of my life dreaming and working towards. So it was really an incredible privilege to get to present these interactions, which is what I had been developing as prototypes and then working to actually ship in person. So just a quick story about how I even got to be on this stage. That basically, while I was working on all these prototypes, I made sure to always share my work. And that's sort of a piece of advice for students, is to make sure you always capture videos, write reports, and show prototypes to people of your work. And I had been doing that, sharing videos to various channels we had internally. And people were pretty excited about those videos. So one day I got asked to present it to a big all hands, but to about maybe 100 people or so. And I was so excited to get to present this work that I think that really showed through that genuine excitement, because I was actually, it's very rare that you get to really revolutionize things, to come up with a new input paradigm. So I was thrilled to get to do that. And So I did a good job at that presentation. I think that was my trial run. And we sort of joked at the end. I was thanking Alex for giving me the opportunity. He said, oh yeah, the next one will be in, when we announce HoloLens. So that's how it happened. And they basically said, well, do you want to do it for the real announcement? And I said, sure. And then actually worked with the team to help build this demo. We had an amazing team that did a really great job. And it was really cool to get to put in these prototypes that I had actually worked on. And I'll show you actually the original prototypes that sort of informed this demo. So when we say that this presentation, we had been building prototypes to explore what are some good ways to interact with our hands, that's true. And I'll show you those demos shortly. So yeah, that's kind of the backstory for how I got to do this presentation. I'm going to move on since we don't have that much time, but that's sort of the end. I think of that as well, actually it's not really, it's sort of just the beginning, but that's sort of I guess one of the most exciting things about getting to work here at Microsoft. Oh yeah, I guess this part about pushing buttons is really awesome also. Just because it's true that we notice that the way that they actually change their hand shape based on the size of the button. So basically the way that a UX control looks impacts how you interact with it. So for big buttons, people would use their whole hand, whereas for smaller buttons, they would use their fingers. For people that are curious what this felt like to me, so I actually saw this whole UI from my HoloLens headset. So if I had done a mixed reality capture, you would see me seeing exactly a duplicate of this. The people in the audience, what they saw was me sort of interacting in front of the air, but then behind me were these massive screens, and I think most people were looking behind me for this. So that's sort of an idea. And the way that this was captured is I'm seeing the holograms, I'm interacting with them. There's a camera that is seeing me, and then it's also seeing the holograms that I'm interacting with. And then it's compositing or layering, it's called compositing, layering the camera view and then the hologram view. So yeah, that's, we actually, at Build last year, we showed how you can recreate this demo using a tool called Spectator View, which is available and open sourced on GitHub, so that you can actually use your phone, which does the same technology as we had for that demo, compositing on the video feed with the hologram feed. Okay, so sort of that's this experience of getting to make this really incredible high-profile demo and having the interactions you've been working on actually getting to see them shipped to so many people around the world and inspire people. So how did I sort of get there with the background? Like many of you, I started out just working really hard in school and doing many side projects. So my advice is to do as many side projects as you can and as many hackathons, because you'll meet really interesting people, and also you will learn lots of new things. So that's kind of the advice there. So I had done an undergraduate, and then I also did a PhD. And the PhD, I think the best thing about that is you get to meet a lot of really interesting people. And also do many, again, side projects. So one of the people I met at grad school was Chris Harrison and Robert Shao. And we had basically done this project where you can detect how you're touching a touch screen by listening to the sound it makes when you touch on your phone. And we did that as a research project, and then we decided to spin it off in a startup. So, and that's another kind of opportunity that doing a PhD gives you, is you have a lot of freedom to do things like do a startup. And I definitely highly recommend that experience, because you are forced to wear many hats and do so many things. So you learn so much, and you learn about how to do things like give presentations, how to coordinate people, and so on. So that was a really important experience. And I'm really happy that we was able to do that before joining big company Microsoft. So why HoloLens? As I was looking to make a change off of my startup, I was sort of trying to think, what's the next big thing? And somebody who really inspired me a lot was Brett Victor. And I highly recommend searching for the humane representation of thought, or just Brett Victor. One day, I highly recommend looking at his videos, because he really inspires me constantly with his work. And one of the big things that Brett Victor kind of reminded us all of is that if you think about sort of the way numbers were represented before, at the very beginning, sort of beginning of our civilization, we didn't have any way to represent numbers, maybe except on our fingers. Then we sort of had different number systems, for example, like Roman numerals. And once we started to have the Arabic style numerals, that really expanded the ways and the mathematics that we can do. And as we introduce more math symbols and ways to represent math, we can do even more advanced math. So right now we have all these great tools for drawing in 2D, drawing graphs and pictures. And my belief is that once we can represent these things in 3D so dynamically, like we can with 2D on screens, and we can talk about it together. So again, just like we had talked about before, the presenters before, they mentioned the importance of collaboration. That once we can talk about dynamic 3D content together, like these two people are in the presentation, that will create, that will allow us to think new thoughts and come up with new ideas, which is sort of what I care about the most, is building tools to help people think better. So that's why I chose to really pursue HoloLens. And when I started, the day I accepted the offer, I think, from Microsoft was the day they announced HoloLens 1. And I saw that I could make an immediate contribution because HoloLens 1 had this interaction model where you sort of look with your head and you tap with your hand. Sort of your head is the mouse and then you click by tapping. And my PhD was in sort of using machine learning to improve user interaction, input and interaction. So I immediately thought, okay, we can do much better than looking and tapping with your hands. And I had done a lot with Kinect and hand tracking. And I immediately thought what we should be doing is just directly touching the holograms that we can see. And in fact, that's pretty much when I would share the HoloLens with my friends, that's what they did, is they would reach out and touch the holograms. But it's important to note that there are advantages to HoloLens 1. For example, the head is very precise. So for super precise input, the head works very well. HoloLens 2 head tracking is exceptionally good. A disadvantage is teaching that air tap gesture is quite difficult. And I have, from firsthand experience, spent quite a long time teaching people how to do this gesture, which is another reason why explicit gestures are not as good as just direct interaction. If you press a button, no one has trouble understanding that they need to press a button, but a gesture is a little bit harder. So from that, let's talk really quickly about some of the prototypes that I worked on with my colleagues that actually got us to HoloLens 2 and the interaction model. When HoloLens 2 was starting out, we had this technology for hand tracking, but there was no proof or demonstration that the hand tracking would be good enough so that you could change the interface moving away from the head and the air tap. We thought maybe it would be sort of an experimental feature, because until someone proves via prototypes and demonstrations and research that you can in fact use hand tracking for the interfaces, that's probably not necessarily going to ship until you have sort of proof. You need to convince an entire organization to do this. So let me show you a couple of the prototypes. This is the very first one. This is actually my Intro to Unity project. Basically, Unity is a game engine that many people use to build HoloLens. Not the only one, but this is the first thing I did for HoloLens was what I said was, okay, let's ignore the fact that the head is supposed to be the cursor. There's all this guidance, but let's hold that off and say, what if the hand could be the cursor instead? And I sort of made this cube that you could pull the edges of the vertices around. And this was probably one of the best demos I've ever made, incredibly, because it was so simple, but it got people to realize, oh my goodness, this is so powerful. So a couple things here that are very important that made this demo really good was that the interaction was very direct. So you can see that I'm pulling the vertices and it's following my hand quite closely. I also removed all smoothing. So we had lots of ways to smooth the hand data, which, however, it's good, and that's a lot of the things that we recommend. But for a demo, what I wanted to do is make it feel as connected as possible, which meant zero smoothing. So I figured out how to do that. And then I also provided visual and audio cues, very simple ones. So I would play a sound when you grab and then change the color of the little purple corners as you pinch. So why did I do that? Because it's very important in AR and VR, especially in AR, to have the system communicate the state of the UI to the user, meaning that the system needs to show you, because it's all gesture recognition, the system needs to show you, yes, I know that you're grabbing. So if you play a sound and do a visual, that sort of helps the user understand that the computer understands her. Okay, and the other reason why visual and audio feedback is so important with AR is because a lot of time you're interacting in the air, especially with things like buttons that you're pressing in the air. You're not actually physically touching anything, so you don't have that haptic feedback that you normally have with real physical objects. So what you can do, and this is something that we discovered through our research, is that the audio and visual can compensate for the lack of actual touching. That people's brains are very flexible. The brain sort of makes it real. So as you see a visual and you hear a sound, it sort of tricks your brain to thinking, oh, okay, I've actually sort of touched something or hit something. Okay, so you remember I mentioned that I was going to show you the demo that the HoloLens 2 announcement video was sort of inspired by. This is it. So this is what we talk about when I talk about in that HoloLens 2 announcement video that we explored as many different ways as we could to interact with objects. Here's the original demo for that. So as you see, what we basically were wondering is sort of what are all the ways that you can interact with 3D UI controls? What if you could just take all of the 3D UI controls in the world and then make them interactive? And we tried as many different things as we could, and we looked at what worked and what didn't. So this is another piece of advice I would have for students, is to take what I call is the shotgun approach. Basically, try many things, and don't be biased. If you think you have a good idea but people actually don't like it, that's okay, that's normal. Throw it away, try something else. And this is exactly what we did. We built like 10 different ways to do things. And surprisingly, we found that there were a couple that people really liked. So they really liked pressing buttons, and they really liked the pinch slider. And all the other ones sort of were okay, but not nearly as strong. And from this, we also learned things that didn't work. So something that people really liked was what they thought they would like is grabbing a knob and twisting it with their hand. But actually, we learned that that's very hard to detect. So you really, with AR and VR especially, things that you think will work may not work. And in fact, they often don't work. And there's always surprises with AR and VR because it isn't exactly like our real world. So it's very important to try as many things as you can and show them to people and get feedback and be open-minded about that. So from these prototypes, a couple of things we learned: press buttons with your fingers, and that feedback, audio and visual, is critical to making AR and VR successful. It is absolutely not enough to just have things move when you touch them. You have to put in that extra design work to add visual changes and also play sounds. So moving along quickly now, here's another thing we worked on, which was how to move objects. So sort of what are good ways? Should you use the wrist? Should you use physics to push objects around? So some things we learned is that the wrist can feel very good for inspection especially, but it's very hard to be precise. So we recommend a bounding box, which I'll show you quickly soon. It's also available in the MRTK. And by the way, as I mentioned, you don't need a HoloLens to actually do sort of MRTK prototyping and to do development. You can do it all from your computer using all free software. So grab objects to manipulate them. If you want to be precise, you should use a bounding box. Pushing things around with physics-style interactions is really great, but very, very challenging. And a way that you can basically cheat, or here's a trick, is that you can constrain those rotations. So don't allow an object to move, just allow it to rotate, for example, and that works much better. So for 2D content, like how do you interact with things like web pages, we didn't really know what would work. So we tried just emulating a touch screen. There's a lot of detailed math that goes into making that feel good. But in general, it works. One piece of advice we have is to just allow one point of interaction per hand. And here's sort of why. This is from a really awesome piece of software that you can get on the Oculus Quest called the Hand Physics Lab. And when you type, they have all the fingers sort of hot and active, and it's very hard to type there. And we learned the same thing, that it's super hard to type if all of your fingers are on. And it works much better when only one finger is able to type. And that's again because your hands are poking in the air, so your fingers are constantly going through. Also, the hand tracking is not perfectly accurate, so you're always modifying your UI to fit sort of the sensing quality. Another really important thing is the finger cursor. So this is very important to help people with targeting in AR because, again, in AR, we don't necessarily show a hand visualization because you can see your hand, but it can sometimes be hard to know exactly how far away your hand is from the 3D content. So that cursor is sort of like a mouse cursor helps you aim. It's the same thing. And this was really important for making the interactions feel successful. In fact, a story is that until we had added that, it's actually was people thought the entire system was broken and hand tracking didn't work. But actually, it's just that they were moving, their hands were just too far in or too far out. So little details like that can make a huge difference in AR and VR. So that's sort of near interaction. For far interaction, we tried many different ways to interact at a distance, and here's some of them. We tried sort of pointing a finger at objects, which is great for pointing, but very difficult if you need to select things because the finger moves a lot as you select. Another thing we tried is the wrist, which everyone tries. Also moves quite a lot when you select, and as you sort of, this is another one where you really need to build it and experience it to try it, but you'll learn that the wrist actually is not as flexible as you think because when you move objects like controllers in the real world, like a pen and pencil, you actually use your fingers a lot more. It's not just your wrist. So the one that we ended up, and then flying hands, which is really fun. It's basically a hand that flies out to the object, which can be really good for things like games and something I still want to, explore. But for a general UI, it just wasn't sort of intuitive enough. And what we landed on was something that's also used in the Quest, Oculus Quest, is this hand ray, which was basically the most stable solution. We sort of tried many, many other things I didn't even share here. And when we looked at what users could do with confidence and accuracy, because that's important for us, this is the one that currently won. But this is still very much something that I think could have a lot of resources to improve. So let's say you're sort of a student and you're so excited by this talk and you really want to get into AR and VR. How do you do that? Here's sort of my advice for you for how to get started. There's several tools that you can learn. One of them is web-based that I think is good. It's called babylon.js if you know JavaScript. Another one is StereoKit, which is just a C# based. For that one, you would need, I think, at least a VR headset. But it's sort of just the bare bones. It gives you bare bones way to add content to your scene. And the big one is Unity. So I definitely would recommend if you want to get into AR and VR to learn the Unity game engine. It's also possible to do Unreal, which is also great, the Unreal game engine. Many of the tools are most mature in Unity. However, Unreal is also a good option. And once you get Unity, the next thing I would highly recommend for people that want to start is to go to aka.ms/MRTK, Mixed Reality Toolkit, or just MRTK. And the reason that MRTK is so great is it doesn't just work on HoloLens or Windows headsets. It works on Vive headset, Oculus headset. It works for phones, AR with your Android or iOS phone. And it even works without any of those, just on your editor, just within Unity. So the place to go is the hand interaction examples scene. That would be when you get MRTK, you can open in Unity, go here, and then press play. And then you can immediately test out all of the interactions using the in-editor input simulation. And in fact, you can write all your code without ever deploying to HoloLens. And in theory, it could work because we're simulating the hand movements here completely. You can find instructions online for how to do this, but basically here I'm pressing and holding spacebar and then moving my mouse, and then you can click. If you click, it'll make the hand press. So this is a really good way to not only test things quickly, but it's great if you don't have a device, but you want to build UI and explore, you can without even needing a HoloLens headset. And many people do this because HoloLens is very expensive currently, hard to get, but you can actually build everything without even needing a HoloLens, which is something that we cared a lot about. And that hand is my hand because I was the person that first sort of built the in-editor input simulation for MRTK. So that's my fault if it's not something that you're happy with. Now, another thing, if you need more flexibility with your hands, is you can also use the Leap Motion hand tracking device. And that's great because it's much cheaper than a HoloLens and much easier to obtain. So you can do this without even needing a VR headset. You can actually hit play and put the leap motion sensor and use your hands. Or if you have a VR headset, you can put the leap motion sensor on the VR headset and do that as well. And this is brand new. We just added it in MRTK 2.4. Another thing I would recommend if you're wanting to do prototyping and research is to leverage recording and playback of hand data. So you can actually record hand movements, save them to a file, and then load them up. And that's very good for debugging. I use that a lot when building prototypes and also when refining algorithms for the really tricky cases. Now here's an example of just how to write to a file that we present. And I wanted to close with some challenges and opportunities for folks. Things that are still very open questions is how do you interact at a distance? Doing physics-based interactions, how to do what I call low-calorie interactions, or come up with interaction techniques that are low effort, not that hard. I think it's important for us to have standards for the UX controls in AR and VR. And of course, we need to come up with ways to sort of iterate more quickly. It still can take a while to get your applications on the device to test. So some of the web-based tools are really exciting here with WebXR, because then you just modify your JavaScript and hit refresh on the browser. So for some takeaways, I'd highly recommend when you're building HoloLens applications, use visuals and sound in your feedback to avoid sort of one-off gestures and instead use familiar interactions like pressing buttons and moving. And most importantly, to always have lots of side projects, always be prototyping, to try many things, show them to people, get feedback, and keep an open mind. And do lots of hackathons, and yeah, keep listening to talks like this and to talks of others so you can get ideas for yourself and inspiration. Okay, thank you. That's it. And here's a bunch of resources if people want to get them later, and some good Twitter handles to follow. Okay, thank you.
Julia. We had some questions in the chat as well.
Okay,
if
sure.
you can pass them on. So someone asked, regarding prototyping for mixed reality, it being sort of slow, they're saying, and the feedback, it can be a lot of, that can require a lot of effort. How do you balance building the idea further or jumping onto another aspect?
Oh yeah, that's a really great question. We face that a lot. Okay, so what I would do often is, so for really good ideas like the Minecraft cube, honestly, the best ideas are often, you don't need to refine a lot. So what you do is you try many things, and even in a non-perfect state, it's so powerful that people really like it, and you can continue to refine it. But what you really look for is these kind of moments where it's so much better. But those are rare. Those are very rare. Most of the time, you kind of get something in between, and a great example of that is the FAR interaction prototyping. So it is really hard to know when to stop with FAR interaction. And I think usually there's a saying that the product is done when it ships, meaning you can keep refining and eventually you have to ship. And so what you need to do is always know what your best option is. And when the deadline comes up, you just pick the best one. So I do a little bit of a combination. So one thing is you try many things at a low fidelity, and you look for, it sort of requires a little bit of experience, but I can tell you if people get very excited, you will know. So it depends sort of on the culture of where you're at in your company, but you can kind of tell if you do many things, you'll know the one that's really, really good because they'll want to keep doing it over and over again. So you look for those, and those you can do very quickly. And then there's some things that you just need to keep refining over and over again. And for those, I think the answer is you always keep trying. So once you get stuck, you kind of take a break for maybe a month or two, and then you come back to it and you try some new idea. And another important thing is it's important to get some things very, very high quality, and other things can be less high quality. For interaction, the visuals need to be simple, but not necessarily beautiful. So these are very simple visuals. This one I had help with the designer on, but like many of the other ones that I did, that was just me with very simple visuals. But the math needs to be solid. So the interaction needs to be almost perfect. And if something doesn't work a little bit for a person, I would actually spend a lot of time getting the interaction details right. Many of these prototypes took me about 1 or 2 weeks, just to give you a sense of timing. I mean, the Minecraft cube took me one night. I think it maybe 2 days, I think one night, and then I refined it a little bit, but it was very fast. This took me about a week or two. But what I would do is I would have someone try it, and when they would say it jumped, the block jumped when I pressed, you have to fix bugs like that. But I didn't, as you can see, the visuals were kind of developer art quality. Yeah.
How important would you say audio fits into there?
Very important. So many developers, like many of my coworkers, didn't think about audio, but all of these, I actually spent time to get high quality audio sounds, and for every single control, there's audio feedback. So the knobs, as you turn it, they play a clicking sound. It's like click, 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 as you move. For all of the sliders, there was sound. Sound is super important. So it's like you need to use sound and visuals to communicate the art, but it doesn't have to be a visual masterpiece. You just need to make sure that the visuals communicate the state.
Well, thank you. We had another question, which was regarding ML. So what's the future of mixed reality with machine learning and any trending research areas?
Oh, yeah, I think we're really just getting started there. Obviously, we have a lot of computer vision in many of the, computer vision, which translates sensor data into input data. But what we aren't doing, what I would love to see more of, and this is an opportunity, is then how do you apply machine learning to input data to make user interfaces more personalized, to sort of figure out, based on hand motions, what did the person intend to do? So I did a little bit of that for my PhD, but I think there's so much more possibility there. So I think it's a huge, very important part, because right now we're using a lot of heuristics, like rules, just hand-tuned sort of custom values. But what we really need to do, what will scale much better, is to use machine learning to, as a person uses the UI, to improve it as they're using it, and also to build like more intuitive interfaces.
Mm-hmm. I very much agree with this whole intuitive interface thing which you're talking about, because when I did my HoloLens project, it was like, yes, it's sort of it's a cool thing to do in the office, but is actually applicable in the scenario, because you could just take out your phone and just scan everywhere. But where I found my project was more applicable was, say, if you go into into a work environment where you have to hold equipment in your hands, that's where it really helps. Or say if you need to go into a minefield, you don't really have the ability to be holding certain equipment, so you need to have something which you can't really use. So the HCI aspect is very much something I think should be taken into consideration. So I really thank you for the interactivity which you've done research into.
Yeah, I really think we're just getting started. Like, these are so basic, and we have so much to do. There's a lot of opportunity here in this area. Okay.
We had another question. Someone asked about live calls. So what I want to mention is the spatial thing. Julia did show a bit of spatial here. So if Julia wants to talk a bit more about that, that's a really cool way to do live calls with others.
Did you mean like the company Spatial, like the software that they have?
Yes.
I mean, I'm a huge fan of sort of collaboration and mixed reality. I think it's really going to change how we work together, and I highly recommend spending time to. It's technically still challenging. Like, it's surprisingly. There's definitely beginnings of toolkits out there to allow you to build collaborative mixed reality experiences. And I think that the key to making mixed reality really go mainstream is having that sort of ability to collaborate with people. So that's really important, is you need to be able to share things between people. I think that's all I can say about the collaboration for now.
Faizan, you there? I think you wanted to say something as well.
No, yeah, there was a question in the chat too that other than Unity, which engines are supported for mixed reality development?
Oh yeah. So just as a side note, you can do, so if you know how to do DirectX API programming, you can use C++ with DirectX to build your sort of, it doesn't require Unity, that's just a tool that makes it easier. So another really good one is the Unreal Engine. So we actually have the mixed reality toolkit for Unreal also that has UI controls, and they're currently working. I know the team really well. I worked with them and sort of to give them sort of requirements for their UI controls. Many of the people that build the UI controls for Unity MRTK are now working on MRTK Unreal. And so that's another really good game engine that has this infrastructure to work with HoloLens UX controls specifically. So that's another really good one. But also WebXR. So if you know web development and sort of there's Babylon JS, which is another really good one. So basically, if you implement the WebXR APIs in your JavaScript code, you can, and then you install the Firefox Reality Browser on HoloLens. You can visit a web page and then hit play, and it will bring you into that immersive experience as well. So those are the main ones.
Yeah, another framework which I explored into was Wikitude. That I think if you're into web dev, that's a nice one to explore as well. And then again, Vuforia, if you can use that within like Unity with C# scripts and stuff, which is the one I used.
Yeah, so here's sort of the Stereo Kit is another one that's built by an engineer, one-person team. Really impressive what he's done, Nick Klingensmith, and that's all C#. And that kind of Unity is a very big game engine. Stereo Kit it's if anyone has done processing with Java, Java, the processing sort of libraries, it's sort of, I think of it as processing for HoloLens. So you just very easy to add cubes and spheres to the world and do basic logic. It's really good for prototyping. Okay.
Awesome. Any more questions in the chat? Let's just have another check. Quick scan. Oh, we have a question which says, I'm actually starting the human-computer interaction major at CMU. What's the best way to keep myself imagining, experimenting, and going outside the box when working on HCI projects? So human-computer interaction.
That's awesome. Yeah, I also went to CMU for my PhD, so that's great. It's a really amazing, you're in very good hands. There's a lot of really creative people there. So one would just be to talk to your peers. I would highly recommend joining the HoloLens Slack channel. So that would be aka.ms/holodevelopers, or this, I'd recommend screenshotting this and then looking at these links. And the other thing that I do is there's a lot of great creative coders that I follow on Twitter. So you can, look on Twitter and look at people that I'm following, or that Yoon Park is following, Creative Park, and sort of follow those same people. They will help you sort of keep you inspired. So there's the thing I do is I'm just always have my finger on the pulse by going to that Slack channel. There's another Discord channel, or on Discord there's a group of hand interaction experts. I'm always reading like research papers that are coming out from Kai and Wist. So you just have to spend a lot of time reading, I guess, and browsing the internet. And it requires a lot of and trying out games, and not just focusing on your one thing of like, oh, if you do HoloLens, it's just HoloLens. You should really be trying out everything that exists. Yeah, that's it.
Yeah, that was good. That about the web thing that you mentioned, I would just like to mention another thing that was introduced in mixed reality developer days. It was announced there. So the Firefox reality. So WebXR. So have you tried that thing?
Yeah, I love it. I'm always looking for ways to speed up my iteration time, because I don't like waiting a minute to deploy to HoloLens. So I built an experiment where there's like a spinning cube, and I just have like my hand raised, and the thing I really want is be able to simulate the hand in the web, so that I don't even to debug my code, I don't even need to put on the HoloLens, because actually putting on the HoloLens and hitting refresh and then entering takes 15 seconds. So I think it's really promising. I'm a big fan of that. I'd love to see MRTK for the WebXR. So, and in fact, there actually is a port of it. Somebody took MRTK and deployed it to web using WebGL. And I think that's somewhere in my Twitter feed. I liked it. Yeah.
I saw that tweet. Okay, so yeah, even I'm waiting for just to grab the HoloLens from my institution and try WebExer on that. Okay, thank you, Julia. I guess that's it. There are no more questions in the chat.
Yeah, there was one, but I think they removed their question. So if you want to ask that again, Nitin, do forward that. We can forward it on. But yeah, thank you everyone so much for being here. Do we have any final words from Faizan, Julia, Ki, Cheng Han, Apan, or Sundar?
I guess Julia left. All right, that's fine.
I have one thing, which is I love seeing what people create with mixed reality and HoloLens, and I'd highly recommend to share GIFs of what you're doing on Twitter. That's a great place to share and get sort of recognition. So really recommend trying to build things and share your work.
Definitely.
Yeah, awesome.
As Julia did say, a lot of it, like, it might just take like one day, like, or like a week. Like, so a lot of the stuff, the easiest part might be it's the whole 80-20% rule. I feel a lot with this. You can get a lot done in a short amount of time, but then the refining is where it gets a lot harder. So do give it a try. I definitely recommend it. Like my experience with it, I never used it. Gave it about a week and I had a project going. So like, you just give it a try. The way I did it, I started on a phone, not on the laptop, using webcam, transitioned it to the phone and then the HoloLens. So you don't have to have a HoloLens, as even Julia was mentioning. You can use your devices and then use a mixed reality toolkit. You don't need to actually own a device. So give that a try.
Yep. Yeah, so those who don't have HoloLens right now, so they can just go on in Unity and try with mixed reality toolkit and just try making an interactive app and just enjoy. The mixed reality toolkit itself is a really great thing to start with, and it's really enjoying. So even I have had a very great experience up till now.
Yeah. Also, Hello Holo, they have their company Facebook and everything. If you do want to check those out, they've posted the link now in the chat as well. So check them out. Thank you all so much, everyone. Sorry, was someone saying something? Did I miss that?
No. Yeah, that's it. And yes, we are out of time. So thank you everyone for joining. Thank you, Amazon Sphere, for hosting this amazing session. And I can't thank much enough to Julia Schwarz for taking out time and joining us here and sharing these so much insightful thoughts with us. If you want to know more about Julia, you can connect to her on Twitter. She had shown her Twitter ID. Someone posted in chat. All right. That's it. That's it from our side. Thank you, everyone.
Thank you.
Thank you. Bye-bye.
Bye.
When it's gone.